Okay, let's try this out. Bro, do you even lift? Pascal's law, let's use it. So the hydraulic lift in a car repair shop has an output diameter of 30 centimeters. And it's used to lift cars up to 2,600 kilograms. Determine the fluid gauge pressure that must be maintained in the reservoir. Okay, so what is the pressure in the reservoir above atmospheric to be able to lift these kind of cars? Well, we have an area, sort of. We have a diameter that can lead us to area. We have a mass which can lead us to a weight. So both those things can give us what we need for pressure. So let's get right into it. Now here is what I'm trying to draw. So I have some sort of atmospheric pressure pressing down at the top, as well as the weight of a car pressing down at the top. I'm trying to figure out what the gauge pressure is on the inside of the reservoir, which is pushing up on that lift. Now, if you remember, our gauge pressure is equal to our absolute pressure minus atmospheric. Well, if I look at that then, so my absolute pressure is going to be equal to my atmospheric pressure plus the pressure from the car. If I plug that in, what I see is that my gauge pressure is simply going to be equal to the pressure of the car. Now, if you're not quite sure where that came from, let me just go ahead and make it incredibly straightforward. So my gauge pressure right here, I'm going to plug this in here. We're going to see what happens. So P gauge minus, make sure I do this right, is equal to P atmospheric plus weight over area minus P atmospheric. There we go. These two cancel. That's what I'm left with. So that's how I get to this equation right here. Okay, now we need to figure out the pressure, the weight, and the area. First off, weight is just mass times gravity. Since it's kilograms, I use 9.81 meters per second squared. If I had a mass in slugs, yes, that's a mass unit, I would need to use that gravity is equal to 32.2 feet per second squared. If I had it in pound mass, just don't do it. Convert to kilograms. Kilograms is way better, okay? It's just way better. Now, how do I find the area? Well, it gives me a diameter. Whenever it says diameter, you're looking at a circle here. So if I know the diameter, I can figure out the area using my area equation for a circle. Pi d squared over 4. Or you might be more familiar with pi r squared. That works too. Plug those in there, being very careful that I convert to meters instead of centimeters, and I get 0.0707 meters squared. Now, with those two, I can plug it in to solve my problem. I get the gauge pressure is equal to 25,506 newtons. Remember, a kilogram times a meter per second squared is a newton, over 0.0707 meters squared. This also can be seen as 360.84 kilonewton meters squared. Kilo means thousand, so that's 360,840 newtons per meter squared. And a newton per meter squared, that right there is equal to a Pascal. So it's 360.84 kilopascal. That is the gauge pressure. That is my answer. So not too terrible. We're just using a few of the equations that we have to solve these problems. Cool. Thanks for listening. I'll see you all next time. Bye-bye.